All right, we're live. It is Wednesday, April 22nd, 2020. Um, and today I'm going to be taking a look at CommandBox task runners, picking up where I left off last week. Bear with me too. I've got a slightly new setup for streaming, so it might run into some issues, but that's not uncommon. Um, so just a refresher for myself where I left off. Let me pull open. I've got a task that I made here, um, and we left off in the docs taking a look at downloading files using the progress bar that CommandBox supplies. So I'm having a weird issue here with the sidebar. Don't know why it's doing that. I think it's because it's zoomed in, but all right, well, this might be a little small for you to see, but it's keeping Safari from messing that up. So we used the progress bar, we injected it, and then we used it to download a random file. So if we take a look at our task here, we got our progress bar and our downloader and the formatter util that we're not using now. We just provided that earlier. And within our run method, we're downloading a random Unsplash image that I had found, and we're sticking it within the current working directory, and we're calling it test.jpg. So it's pulling this down, naming it that, and putting it in the directory. And we're just using the template code for the downloader here. So if we hop over to the terminal, we have that. So let's see what happens here if the file already exists. If we do task run, is it because we're not in CommandBox? That would be why. Always be in CommandBox. All right, within CommandBox here, we'll do task run to see how that executes. And it's going to, I'll get the download bar, and we've got that file there. So if we open it, all right, it opened on my other screen, but I can pull it over here. And you'll see that it certainly downloaded the Unsplash file and put it there. So that was a decent place to leave off. And I am really impressed with the that downloader. Makes it really easy to integrate. And I'm trying to think of some tool where you could grab images from Unsplash and provide them to the user. But all in all, that's really handy. So we're going to move on in the docs from, I don't think there was anything else in this download section. All right, let's just see if we can move that over. Why? All right, you know what? There we go. We'll just get rid of the sidebar entirely. That's working. Cool. All right, downloading files. We injected it. We downloaded the file. Okay. The closure is a callback that updates the progress bar as the file downloads. So you can make your own progress bar, which I'm not interested in doing. And the error will be thrown if the status code is less than 200 or greater than 399. And we could follow redirects if we wanted to. Okay, I think that's sufficient for digging into that for now. We'll hop over to running other commands. Okay, so this is something that I'm loosely familiar with because this is in the custom commands that I've worked with. But CommandBox, it's a CLI, it has commands. So within our task here, we can run other commands using the command DSL here. So DSL is a chain sequence of methods. They end in a run method. That's what should happen. So, let's just copy the most basic example here. Now, I like this run method. I don't want to lose it. So we'll stick it down here and we'll call it download image, just so that we have that on hand. And then in here, we'll paste that, running that command version run. Hop back to the terminal, task run, and it prints out. You can see I'm running the 5.0.2 alpha of CommandBox. I don't think Brad's done any updates since this morning. Oh, obviously I spoke too soon there. Why not? Let's download that. And then our task will show us our updated version of CommandBox. So we're at the alpha 165. If we rebox here, and we run our task again, we're at the alpha 166. Very cool. All right, so let's see what else we can do with commands. All right, so with commands, you can pass in params, flags. Obviously, you need command. That makes sense. Params method is used to pass parameters to your command. Names are positional. That's very nice. Flags, we can pass in and then run them. You may redirect the output of a command to a file by chaining the append or overwrite methods, which are mutually exclusive. All right, so let's just give that a shot. How would we do that? Let's copy these. Let's drop them in here. We'll comment this out for now. I'm not going to cat anything. What command are we going to run here? So this is going to be our output file. The params that we're going to pass into this command. All right, let's just hop into terminal here, and we'll run help, which will give us a list of commands that we can run, just to see if there's one here that's interesting. Echo cfml. Well, you know what? We don't. Oh well. If we wanna. Oh, I guess we do just echo it in. Sorry. Talking to myself here. What are the log commands that they have in here? Maybe a log one would be interesting. Recipe, REPL, run, system log. System log, help. Outputs the path to the system log file. Combine with other commands to print the. I don't want to open those. All right, you know what? We're not gonna be too creative here. Well, we could do something like file info on that test.jpg. Let's see if I get the syntax right here. File paths tend to mess me up. And we'll say that, okay, this is var file, file info equals that, and then we'll echo. Wonder if this will work. I don't remember what file info returns, so we will go to Safari and cfdocs. File info, it's not file ingo. Isn't it file info? File get info? What is it? Get file info. and it will return the struct with size. That's what we want. So we'll do get file info on that, and then we'll pass in file info.size. Actually, we'll pass in the sentence. And we'll say, this is all a lot of work for running a basic command. We'll say the image is this size, because I don't know. And that's going to get generated into an output.txt file. Now, output.txt doesn't exist, so I am curious whether it's going to create that or not. So here we will run the task, and we'll hop back to this, and we'll open output.txt. Oh, there we go. So we were able to run the echo command, but we used the echo command, and then with the echo command passed in params to it. So we echoed this into the output.txt file, which did not exist, so it got created, which is very cool. And now I imagine if we ran it again, let's just see what else we can get here. Type. The type of file is, since we're doing the append command, I imagine we'll just get this on a second line in that output.txt file. No. Really helpful info there. The type of file is file. Thank you, get file info. And then if we wanted to do overwrite, we could blot out the content of that file using last modified. And then this will just say the file was last modified. And we could format that if we want, but we're not going to. Awesome. So that overwrote the file. That's actually really handy to be able to get the contents of those commands that you run in a file. In working directory is an option. Control the working directory that the command runs in if you don't want it to be the current working directory of the shell. Convenient if we were customizing it. I don't think I necessarily want to play around with that right now. Pipe. Piping is a very powerful way to combine multiple commands. It comes via the pipe method. This method expects to receive another command DSL instance. You don't need to call run on the nested command. You know what, rather than trying to fudge this myself, I'm just going to run the example first. Take a look at it. Command, so we're running echo here. We're passing in hello world, and then so are we piping, which one, what are we piping into what here? Okay. So let's see what this does. Hello. So we grepped low. Okay. I'll be honest here. Why? Let's take a look at this example again. Hello world. You know what? This is, yeah, I'll let myself be embarrassed. I gotta run grep help here because I forget exactly how grep works. Search through a string input and filter only matching lines. Okay. Okay. And then grep can take globbing, I guess. So let's hop back to this example just to make sure that I understand grep. Hello world. And then we'll add another, we'll say hello world. Turtle. And if we grep in UR, we will get turtle back from this. We got turtle back. Okay. So I think part of the, if you're going to end up using the command DSL here with pipe, you've got to be pretty fluent in the command line to begin with to know what commands you want to pipe in to other commands. Helpful to know that you can do it. I don't see for myself a particular need to be able to use this. I think in most cases, if I needed to do some more complex manipulation, I'd be doing it with CFML outside of this, but it's there. Okay. You can do multiple pipes. Very cool. Set is powerful. All right, cool. Your DSL should always end with a run method. Just jumping back here to lest you think that I think this is useless. I've run lots of commands in custom commands that I've built. It is really helpful to be able to run commands from the command line because a lot of times, unlike echo, but there are commands in here in CommandBox that streamline dealing with text and input where you don't need to write the code, you can just use it. So being able to do that is super helpful. By default, the output will always be sent to the console. However, you can capture by specifying return output as true. Okay, so let's just grab the example here again so that we can see what's going on. All right, so in this case, because return output is true, this doesn't mean return output to the console, it means return output as a variable. So rather than echoing this to the console like it was in previous examples, this is all getting returned as the output variable. And then we could print this both ways probably. Print dot line output. So the first time it's going to print it as unANSI, and the next time it'll print it as ANSI formatted. To clear this so we can see what's going on. All right, why did we get only one? Oh, let's not do that. Let's do this. All right, so that's not what I expected. Print unANSI output. Print line console. Sometimes stuff exits too soon. All right, so I wonder if unANSI unANSI output equals. I haven't looked at what this unANSI method does, so let's just say Print.ling is not what we wanted to do. Print line. Let's see what this does. Oh, there's no actual ANSI formatting here, I'm guessing. Interesting. Let's just hop into the docs here and see if there's anything else on what this does. Okay, so while the line method on the printer prints to the console, an ANSI strips output and returns it as a variable, which is why it was only printing once. Good to know. So we're down here. Where are we? Params, flags, in working directory, pipe. This is all visible, right? Run. We can set it as a variable. We can strip formatting, which we didn't really do in that example, but it's possible. Okay, so when we run, there's also an echo option here. So let's take a look at that, because that seems like it says when you're debugging, like it would be helpful. Ooh, typo. Can we do this on the fly? Optionally. All right. Optionally. Can we do this on the fly? GitHub. I don't know if I'm signed in right now. I am. All right. Oops. Edit. That was pipe. Optionally. Here we go. PRs on the fly. Live coding. Correct. Typo. Okay. That, you know what? Every little bit helps. Close that. All right. If I hadn't corrected it, it would have bothered me. All right, so we can echo true when we run a command. So when we are running this command echo, my name is Brad, we could also into the run method pass, what was it? Echo equals true. And we'll print the output too. Print line. All right. So super convenient here. With echo equals true, it prints out the exact command that you ran, which in this case is straightforward, but yes, for debugging, that seems like a tip that would be absolute gold. So keep that in mind. You may want to manually pipe data into the command. Interesting. I'm not sure why you would want to do this using piped in the run method, but you can. Okay, good to know. If you try to pass a shell expansion into a command, it won't work since the CommandBox DSL escapes all your special characters. This example doesn't work because the special characters are escaped, so the exact text is printed out. You can ask the command DSL to treat your parameters as raw, so they're just passed along. This allows them to include system setting, expansion, and CommandBox backtick expressions. All right, so let's just take a look at this here. And we'll hop over to our task. Don't need that. So echo, helpful for examples. So we'll run this once. We'll do this both ways so we can see. Raw params equals true. Raw params, well, it's going to default to false. And in both these cases, let's do echo equals true so that it shows us what's run. I just kind of like seeing that info, I think. All right. Nice. Well, I broke something. First time tonight, so that's a... All right. Output doesn't exist. Oh. Derp. Let's clear this and run it again. So there is the command run the first time. Interesting. We didn't get any output though. What if I just run that here? Echo. Is that like a built-in CommandBox environment variable? Let's just see. Echo D. Wow. This is typo central. Huh. I don't know what environment variable. It's just, okay, so we're basically done in here, but environment variables, shell environment variables, are any provided by CommandBox? If we, is env a command here? Huh, maybe we don't have, maybe there's none available and that was just an example. There's an env namespace for dealing with environment variables. Okay. CommandBox allows you to access the Java system properties from the CLI, environment variables from your operating system via the name here mechanism. Let's just see what else there is on environment variables. I know that I can set them. I thought, let me just open a new, if I do CNV command, yeah, I've got lots of environment variables there. env show clear debug. All right, well, you know what? I'm not exploring environment variables. Nothing was expanded because it's not showing anything. I'll dig into that more later because I'm more interested in tasks themselves here. So running other commands, whip down to the bottom, and that's all good. Error handling, let's just see what else we have going on here. Where are we? All right. I'll go through error handling, but then I think I want to jump to watchers. We know that we get stack traces when there's unhandled errors because we already got one during this session. If there are expected situations such as a file not existing that you might know go wrong, we could use the error method. Errors returned from the error method will not contain any stack traces, etc. Okay. That is pretty straightforward. So we can return errors ourselves. Can just do it always. Nice. So if we had a task that had expected parameters, that might be a place where that could get used. So if it just had like, first of all, let's just see how it gets handled on its own. So if we said required string name, and then, well, first let's just say print, this is line hi, task run, enter name. So it's, okay. In this case, CommandBox is really helpful. So in that case, the handling doesn't actually get, that's not actually necessary. That's not what we want. All right, so let's hop back over to the task. So in this case, it would be more like if we didn't make the name required, but it wasn't provided, we'd say name. Now this will contain the stack trace. If we run it, because it broke, it'll say name is not defined or something like that. Name doesn't exist. But we could handle this elegantly ourselves. If using the error method, we could say if, how would we do this? Not, well, you know what I'd probably do this. Default it to nothing and say if not name dot trim dot len, probably. Throw the error to include the name parameter because it's an expected error and we're throwing that intentionally. So we can return that error ourselves. And I think the docs said there we could also return an exit code. So that would be message equals and exit code equals 42. We exited with the meaning of life. Oh, and the exit code, I guess, is returned with the error right there. That's kind of helpful, especially for debugging, to include that if you want to handle some known locations for errors manually. All right, so I'm going to jump to hitting your database. I've looked at this before. I don't have, if you're running tasks, basically, because this is using Lucy, you can define your data source as a struct, which enables you to run queries against it. For running through the docs and just in my general uses, I don't have a data source that I need my tasks to hit. This is probably super helpful if you're using your tasks, you know, in production to run scheduled things or to transfer data between databases. Basically, you define your data source and you can run queries. But I won't be doing this in the demo there. Interactive jobs. Sometime, I'll probably come back to the job DSL. I've been going for how long? 35 minutes. So I just want to make sure that I get to dive into watchers because that's one of the things that I was interested. So I'm going to do watchers, and then if I get through that, maybe I'll jump back to interactive jobs at the end, because watchers is something that I'm particularly interested in, and I've sort of used, but not all that much. So as I understand it, and we'll confirm or deny this, watchers are a type of task, or using watchers within a task. I guess it doesn't have to be a task, that just watches the file system for code changes and can do things when changes happen. So it blocks further processing until you make some change, and then it fires the trigger. To use a watcher in your task, there's a method called watch. Nice little DSL. So what should it watch? In what directory? How often should it check for changes? And then what should it do when the changes happen? So we'll start with this. All right, we're going to move this out of the way. And we'll put this within our run method here, the example watch. So it's watching the current directory for CFC files. Something has changed. So I'm intrigued at what information gets passed to this onChange method. Let's look for we have those txt files. So let's look at them. Txt files in the current directory with a 5-second delay, I'm guessing, prints a line saying that something has changed. Let's just do that first. So that's there. In here, we'll clear it and we'll do task run. Now what this is going to do is it's going to be blocking. So it's just watching the files now. This is okay. So we're watching for txt files. If we touch example.txt, we should see that get picked up here. Maybe it doesn't necessarily see new files that are added. ls. And we were watching txt files, right? Yeah, we're supposed to be watching txt files. I would have thought that would have triggered it. No, this is something that I'm terrible at. This is echoing and piping. If we echo test, how do I echo that into a file? 1 into output. All right. Cat output. Yeah, that worked. Huh. All right, so I messed something up here because I would think that this would be printing something's changed, particularly when the file was added and when I added text to it. You know what we can do here? Let's open up output. Maybe the test. Let's do it that way. Still nothing caught by the watcher. This is good because it's an error and I should learn from it. In directory sets the base directory the file globs are relative, defaults to the current working directory. So this is unnecessary, but that works. It's polling every 5 seconds, but I think we waited 5 seconds and we didn't see anything here. So that's not why this is slow. On change, closure, and start. It's starting. If you don't care what the change was, all right, so a struct is passed in to the onChange function. Actually, this is much more helpful. So we're going to add paths. Well, first of all, we'll stop this because that didn't. Oh, weird. So we printed things here, but they didn't make it. What if we go? This feels like it could be a bug. Let's just try this again before we change it. So we're watching now, and in here we're going to touch test.txt. Okay. In here, if we echo test into that test.txt, that's not the file. We should get another changed here in a second. Okay. So first issue was the printing here, and I'm not sure exactly why. If we didn't force it to the console, wasn't getting flushed to there. Now I wonder. All right, so let's hop back to the demo here before we dig in a little bit more. And let's just run a command along with that function. I'm wondering if that function, so we're going to remove the to console, but we'll run just a random, we'll run an echo command here. Echo, dot params, nope, params, now, okay. So we've tweaked this a little bit. We've removed the to console, and we're seeing if we run a command after that printing, if the printing will actually make it to the console without getting forced there. So we'll change this, clear, run it, it's watching. What we're going to do here, we're going to do rm output, rm. Oh, these actually should all be showing up since removing files is one of the things that it should keep track of. So if we go to 1, we got them. All of them got picked up. Okay, so lesson being test your code. That when you've got just a print line, I guess not enough happens. Maybe it happens too fast for the code to make it all the way back to the console. I'm not sure exactly what's going on there. If you're just printing a line, you need to console, but just by running thing makes it out to the console within this function. We'll jump over to the watchers now and look at that closure. This seemed like a very helpful example function. So we'll grab this and swap it in here. So we're watching, it defaults to the current working directory, so we don't need that. And then we're passing paths. Now I do think, let's just, I think this formatting here is going to break, but we'll see. We're doing print.line, and this should tell us the number of paths added, removed, and changed. I think this formatting, though, is, I don't think it's going to like it. But we'll find out. Interesting. Oh, time out. I stand corrected. Unless you push that right now, unless you push this printing to the console, it doesn't show. The command output was showing, but these print lines were getting swallowed until I killed the function. I don't know if this is PR worthy. I'm not sure if that's a bug or not, but I would expect this code to print to the console, especially because the command after it does. But at least in the example that I have there, this doesn't make it unless to console is added. Good to know. All right, so we're going to do task run, and this is going to be one that's tracking more specifically what's added, removed, and changed. So if we touch test.txt, it's going to tell us that a file was added. Huh. Is this just because we're printing again? Interesting. It's not breaking, but I wonder if this is the same issue. To console. To console. To console. All right, let's just try this. Yeah, clear. Task run. All right, so it's watching again, and if we remove, okay, if we remove that text file, the watcher is broken. Can't call a line on object. Object is null. Now I think in this case, it's because of the formatting. So let's try this. Yeah. Oh, so the watcher has started again. So we'll ls, we'll touch test.txt. If the watcher is running, it should print this to the console. But I don't see anything. Let's just okay. Let's try this one more time. I think because I changed the file, that didn't behave the way I expected. It is watching the files. We're going to remove test.txt. Interesting. It doesn't like line. I'm intrigued here. I would have thought maybe because we're using to console, we can't chain these. Let's try, you know what we're gonna do? We're gonna try this now. If we add the to console at the end, all right, this is probably what we need to have. You know what? Trial and error, third time's the charm. Task run, broken. Fourth time's the charm. What doesn't it like? Invalid identifier, line 17. Derp. Derp, de derp. All right, clear. Fourth time, fifth time's the charm. Watching files. Touch test.txt. One file was added. Now if we echo test into that file, we see that one was changed. And if we remove it, we see that one paths were removed. So it's picking up all of those things. All right, so jumping back, well, let's jump back to the code here. We needed to adjust the example a little bit in order to get it to work. First of all, the formatting with print on a standalone line didn't work. It just kind of borked at that. And I don't know exactly why that's the case, but that didn't work. And then secondly, it's the same issue we saw the first time, that if we didn't use a to console, the printing of the lines was not making it all the way to the output. Okay, so those are the watchers. What we can see here too is we're just printing the length of what changed, but we actually get a list of the files, I'm assuming. So we could write out, since we know that, well, if a file is added, we know that one was there. Let's just adjust this slightly. We'll say if paths dot added dot len. This is not the most elegant. Paths dot remove dot len. We'll have it print these out. And I'm assuming, we're going to try it just to confirm that the to console thing is a thing. We'll try it without to console first, and then we'll update it when it breaks. Changed, removed, get rid of this. So we will see here, as we change those things, the name of the file, and I'm partially just intrigued at the format that comes in. So all right, so nothing's showing because we didn't flush the output to console. So in here, we need to console. I need to ask Brad about this because that's just kind of frustrating if you're working with it for the first time and nothing's showing. Task run. Let's pipe some content into that, and it tells me it was changed. And if we remove it, it tells me it was removed. Now, what might be more helpful in this case is that if we, what is it? We did this last time. I did this last time. File, system. No, I don't even need it. Within here, it's not expand path. How do I get that absolute? file system util resolve path. So resolve path. All right, so if we run it now, we should get the full path to that file that is either added, removed, or changed. Nice. Although that is not where that file was added. That file was added. Interesting. I guess maybe I need to, maybe because I don't have the slash on it, it's assuming that it's in the root. Let's put this in quotes. Let's put it in pounds. And let's throw a slash in front of it. Hop back to the terminal. Stop the watcher. Clear. Reload. I didn't need to reload there. Clear. All right, so task run. It's watching the files. We'll touch a new file here. We'll say test2.txt and okay. So I can't run, I guess it makes sense. I can't run resolve path on just the name of the path itself here. I need to include that slash to indicate that it's relative to this current directory that we're working in. Although I thought resolve path was supposed to give me the absolute path to that file. Huh. This seems a little strange to me. Let's just hop back to the docs here for 1 sec. We are in here. Where are we here? We are within tasks, using parameters, file system paths as parameters. I guess this only works for file system parameters that are passed in as arguments, and maybe not. Maybe let's just try this one more time. This is why I call it trial and error, because the only way to figure it out is by trial and error. Task run, we're watching, and test3.txt. Oops. Well, that gave me well, it just changed. Let's do touch test 3.txt. That's what we're actually looking for. Okay, all right, that worked. Interesting. So not CommandBox, my mistake. I ran initially I ran resolve path not within file system util, and resolve path on its own executed relative to wherever CommandBox is. File system util with resolve path took this parameter and resolved it properly to this directory. To console, though, is something that I think we need to work on. All right. Watchers. Since I've been going for an hour, I don't want to go too much longer. Um, I did want to try to do something neat with this, but I don't think I can tonight. What's really cool here is um, that anything, so you can run this watch, um, and you can pass in some type of glob here. Not in here. You can pass in some type of globber. So you can watch CFM files, CFC files, text files, PDFs, Excel files, um, and then when they come in, you can do something. So, for example, you could run this in a directory, and every time you pass in a CSV, you could convert it to an Excel file and send that in an email. Um, or every time, I don't know, something comes in, you could PDF it and send that as an email. You could do anything you want. Um, I don't know exactly what use I have for watchers, but because they're so powerful, I feel like I have to have some. Um, and I want to explore them a bit more. So I don't think I can go too much longer. I did not get to look at interactive jobs, and I think that's the last big piece that I wanted to look at. Um, yeah, and I'm not going to get to do that tonight. There's a bit much going on there, but we got to work through a bit more. We talked about running other commands and the various options there, error handling, briefly on databases, and then we looked at watchers themselves.